Whoops, sorry about that. Got a little bit cut off, but I think we're back. So what we want to do is match what we're trying to get rid of in our rate equation. So that's f divided by g. So we want to solve for f over g. And so the way that we're going to do that is, so we have f here on the right side. So we want to get that alone. So to do that, we're going to divide the right side of the equation by k minus 4 times the concentration of C times the concentration of D. And now remember, whatever we do to one side of the equal sign, we always want to do to the other. So we're also going to divide that by k minus 4 times C times D. So now this gives us, and I'm just going to pull f to the left side, we're left with k4 times b squared times g divided by, k minus 4 times c times d. And now we're super close. We have f isolated, but we still want to divide it by g. And we have g here in the right side of our equation. So now all we have left to do is divide both sides by f so that we match the f divided by g in our rate law. And so because we're going to do the same thing to both sides, just like we did in this previous step, another simplified way of writing that is just dividing the entire equation by the concentration of G. And what this gives us now is the concentration of F divided by the concentration of G, and that's equal to everything that was left on the right side. So that's K4 times B squared, no longer multiplied by G anymore because we divided it, and so those cancel out on the right side. So it's over K minus 4 times C times D. And I didn't finish that bracket there. So just like we did with the intermediate E all the way up here, we're going to take everything that F divided by G is equal to and plug it into our updated rate law. So things are going to get a little bit messy with all of the different symbols in the algebra. So just try and use as much scrap paper as you need to whenever you're doing these. You'll get an unlimited amount in the exams. So just try and keep track of your work as best as you can so that you can follow each step. And if you need to like number them or write a little bit of a description, definitely go ahead and do that. Whatever will help you keep track of everything on your page. So I'm just going to add a new page down here. And so we're going to take our rate law that's here. So that is the rate of our equation times, you know what, I'll just copy. This down here. Get rid of these. And now we're going to substitute in for F divided by G. So if we do that, we have the rate is equal to K5 times K1 times A to the third power divided by K minus 1. Oops, it's not super clear. Minus 1 times C. And now we're replacing F over G. So we're going to multiply this whole equation by what F over G is equal to. And I'm just going to copy and paste that as well. And then get rid of those equal signs. And of course, it messes up a bunch of things. Okay, so that should be the correct form. So what we'll notice next is that we have a couple of the same concentrations here. So we're just going to simplify this a little bit further because we have two concentrations of C on the bottom, and so we're just going to combine them just like we did previously with the multiple concentrations of A. So now our rate law simplifies to, and I'm going to pull all of the rate constants to the left side of this. So we're going to move K4 over here, and we can move things around spatially because they're all multiplied together, so it doesn't actually matter the order that they appear in the multiplication process. And then all of that is multiplied by A cubed, and now it's B squared divided by, and since there's two C's, that's going to become C squared times D. Okay, so just like we were able to isolate both F and G at the same time and substitute them into our rate law, which we now have an updated version here. We're going to do the exact same thing because what hopefully you'll notice is that we have our reagents up top here, but on the bottom of our equation we have two of our products. So while we've gone and substituted out all of the intermediates in this reaction, we have left ourselves with some of the products of our reaction. And those still have no place in our overall rate law, so we want to isolate them as well. So the way that we're going to do that is just like we were able to do F and G at the same time, we're going to see if we can do C and D at the same time. So we're going to go back up to our all of our rate laws up here. And then we're just going to check off this fourth one because we use that to isolate F and G. And we have two more rate law equations that we can work with. The first has just C in it, but the third step, but the second equation that we have left has both C and D in it. And so this third step is actually the one that we want to use first because in our updated rate law, we have C squared times D, and another way of writing that is just C times D. So we can't use that third step in our mechanism to get rid of all of these products at once, but we can get rid of this C times D first and then afterwards get rid of the last C. So that's what we're going to do. We're going to use this third mechanism step, and I'll copy it and bring it all the way down here with us. So we're going to use this step. We're going to isolate C times D, just like we did isolate F divided by G previously. And then we're going to substitute it in to our updated rate law expression that's up here. So this one is a little bit more simple than isolating F divided by G, because all we have to do to isolate C times D is divide, whoops, still in my highlighter form. We just divide both sides of the equation by K minus 3. So that gives us C times D is equal to K3 divided by K minus 3 times A squared times B. So now we're going to take this right side of the equation and plug it in for C times D. And it's not going to get rid of one of the C's, but that's okay. We'll take care of it in the next step. So we're going to go back to our big rate law that's just growing larger and larger with each substitution. We're going to say the rate is equal to K5 times K1 times K4 divided by K minus 1 times K minus 4. We still have a cubed, B squared, and we still have a C left over because we're only solving for C times D. So one of these is still left over. We're going to take care of it in a little bit. But in place of D now is going to be and I'll write it over here. A squared times B, and that's on the bottom, and I'll get to why that is in a second, and that's multiplied by K minus 3 divided by K3. And so the reason that it's on the bottom here is because that C times D is on the bottom of the fraction of our big rate law. And so this A squared times B appears on the top of the fraction for CD, but CD is on the bottom here, and so it's going to go sort of in this spot here. And so that's going to flip everything in the equation. So they're going to go to the bottom of the fraction, and then this K3 over K minus 3 is going to be flipped like we see here. So we're just going to take the inverse because they're going from the top of the fraction to the bottom of the fraction. And then hopefully we notice that we can cancel out a few things. So we have a few concentrations of A on the top and the bottom, as well as concentrations of B on the top and the bottom. So we're going to try and cancel things out as best as we can. And I'll just do that in another color so we're not getting too confused. So we're going to start with A. So we have 3 A's on the top and 3 A's on the bottom. And another way of writing that, we can just write it all out. A cubed is equal to A times A times A. And if we divide it by A squared, that's equal to A times A. So 2 of the A's on the top are going to cancel out with both of the A's on the bottom. So we're just left with a single concentration of A on the top. And then we can do something very similar for the B's. B squared is the same as B times B, and it's over just a single B. So only one is going to cancel out on the top and the bottom. So we're going to be left with A times B on the top. And so if we add a new page, we can rewrite our rate law expression. And I'm going to take these K values and just move them over to the left so they're combined with all of the other K values that we've been putting into this equation. So that's K5, K1, K4, K minus 3 divided by K minus 1, K minus 4, and K3. And then from our canceling out that's written in pink, we have just 1A and 1B, and that's divided by that last C that we weren't able to solve for in this previous step. So we're super, super close here now. We only have one more substitution step to do, and that is to get rid of this last C. So unfortunately, we couldn't do it when we were getting rid of D and the other concentration of C, but we're going to go back up to our list of rate law equations. We've used the third step now. Our last one is this second mechanism step. And that has our final concentration of C here that we're going to use. So if I go and copy this, we now are, just like we have been, we're going to solve for this C here so that we can plug in that whole equation for the last remaining product in our rate law and hopefully find a rate law that matches the one that we know to be correct from problem 15. So just like previously, to isolate C on one side, we're going to divide both sides by K minus 2, and that gives us the concentration of C equal to K2 over K minus 2 times the concentration of A. So now all of this is going to go in place of C. So just like we did up here, where since we're substituting in something into the bottom of the fraction, it's going to flip everything. Whatever was on the top now becomes the bottom of the fraction. So if we're plugging it into our big rate law, I'm actually just going to copy all of these since it's getting to be a lot. We have all of those rate constants. We have A times B on the top, and now I'm just going to put that over 1. It's going to be multiplied by the inverse of this because that concentration of C was on the bottom of the fraction. So we have A on the bottom, we're going to keep that over 1, and then this fraction with the K values is going to flip. So instead of being K2 over K minus 2, it's going to be K minus 2 over K2. So this is getting all very complicated, but we have finished now substituting in all of our equations for intermediates and products, and now we can just cancel similar things and we can combine all of our small rate constants into one larger rate constant. So what we're going to do, well, we can notice that we have an A, concentration of A on the top of our fraction, concentration of A on the bottom of our fraction. So those are going to cancel out. And then all of the K values, we're just going to say are equal to some arbitrary K. Since we don't know what the numerical version of those K constants are, we want to shorten this. And so we're going to say that our rate is equal to some larger K, or K combined, if you will. And then our A's cancel out. We have the concentration of B left over, and that's it. That's our simplified rate law. So whenever you get to the very end of these types of problems and you have lots of K's, definitely feel free to simplify them into a more simple combined rate constant, and then just cross out anything that's similar, just like we did with the concentrations of A that appeared on the top and the bottom of the fraction. And then that's it. That's all of our algebra. And so the main question that we were asking in this worksheet was, is this mechanism that we just went through a viable mechanism for the reaction that we were doing? And so to answer that original question, we want to compare this rate law that we just calculated to the rate law that we calculated in question number 15. So if we go all the way back up to question 15, we have our rate law is equal to K times the concentration of B, and that's exactly what we just solved for. So this is, in fact, a correct mechanism for the overall reaction we've been working with in this worksheet. So hopefully that helped clear up any sort of lingering questions that you had about this process. Feel free to stop by office hours or email me if you still have questions or want to go through any of the math or the chemistry associated with this. But otherwise, I hope that was helpful, and I'll see you next time.